Okay, good afternoon. This is the first video in the polynomials unit. It's called Intro to Polynomials with adding and subtracting as well. So first I'm going to define what a polynomial is. So a polynomial is the sum or difference of two or more unlike terms. So first I need to tell you, well, what does term mean? If a polynomial is a sum or difference of two or more of them. Here are some examples of terms. 4x, 3x squared, 7xy, 2, negative 5x to the third. These are all examples of terms. And I picked 5 terms that were all unlike, meaning they're all different from each other in a certain important way. And if I take any two of these terms, or more than two of these terms, and I add them together, or take two of them and subtract them, I will have created a polynomial. Poly comes from the Greek meaning many. So since I took two of these terms and put them together in an addition or subtraction expression, that constitutes many, so I can call it a polynomial. If I just take a single one, that's not a polynomial. We call this a monomial. Mono means alone or one. So one term, polynomial. More than one term, polynomial. And as I said, it's at least two. So I could take all of these add them all together, and this is also a polynomial, a very long polynomial. Now I can have polynomials with 2 terms, as you see here, or 3 terms, or 4 terms, etc. If I have a polynomial of 2 terms, it has a special name. This type of polynomial, since there are 2 terms, is called a binomial, 2 terms. If I have a polynomial with 3 terms, like this one, that is called a trinomial. And that's where the special names end. If I had 4 terms, there's no special name for that. Well, there's no special prefix for that, like tri or bi. We just call it a 4-term polynomial. 5 terms, 5-term polynomial, etc. Now let's focus on the little parts, the parts of one term. So I'm going to write the 3x squared term really big here. So this is one term, and we know it's one term because everything in this expression is multiplied. So a term is something where everything is multiplied. This is 3 times x written as 3x squared. So this constitutes a term. And this term has little parts to it. There's a 3, there's the x, and there's the exponent for x. And all of these have special names. So the 3 in this term has a name that you heard us use before, and that is coefficient. So you're familiar with that. The variable in this term x is in the position of base. So x is the base here. And we already know what that is. That's the exponent. So we got coefficient, base, exponent. And the base happens to be a variable, so we sometimes call this the variable base. The base is not always a variable, but in this case it is. Now every term has something called a degree. A degree. The degree of a term is the sum of all the exponents of the variables. I'll put s in parentheses because sometimes we only have one variable. Sum of all the exponents of the variables in the term. So in this term we have one variable and that variable's exponent is 2, so the degree of the term is just 2. We've identified the degree of this term to be 2. So that was an easy identification. Going back to the long polynomial up here, the degree of the first term is 3 because that is the exponent of the only variable there is. The degree of the second term is 2, as I just said. The degree of this term is 1 because that x has an exponent of 1. The degree of the 7xy term is actually 2 because each variable in this term has a 1 for an exponent, and if I add up 1 and 1, I get 2. So the degree of this term is 2. The degree of the last term, which is just a 2, is 0 because there are no variables here. And if there were, the exponent of that variable would be 0 because x to the 0 is 1 and 2 times 1 is 2. So if I see any term without any variables, the degree is 0 because that means that the exponent of that variable was 0, but then that caused that variable to disappear. And for any term where there is no variable, when it's just a number, we call that type of term a constant. A term without variables is called a constant because it stays the same. Terms with variables are variable, meaning they change depending on what the variable is. Okay, the degree of a polynomial is the same as the degree of the term with the highest degree of all the terms in your polynomial. So back to our long polynomial. First, I identify the degree of every term. 3, 2, 1, 2, 0. The highest degree out of all those terms was the degree of the first one. The degree was 3. Therefore, the degree of this polynomial is 3. So the degree of the polynomial takes on the same degree of whichever term had the highest degree. You just take that degree and make it the polynomial's degree. Now, what is this big deal about degree? It's hard to explain in full what the importance of degree of a term is, or what degree of a polynomial is, until we move on to subtopics later in the unit. But the degree of a polynomial is very significant when you put that polynomial in an equation. The degree tells you a lot about how the polynomial behaves. And that's all I'll say about that for the moment. Okay, adding and subtracting polynomials. You can think of adding and subtracting polynomials as combining like terms. And that's something we've heard before. When we had equations with terms that some of which had x's and terms that didn't have x's, we often had to combine like terms before fully solving the equation. Well, we had to identify like terms in order to do that. 3x and 5x, like terms, and we put them together. 7 and 2, like terms, so we put those together. So think back to that when we identify like terms in polynomials. So here's a polynomial that has some like terms in it. Okay, so how to identify like terms? Like terms are terms that have, first of all, the same variables, but they also must have the same exponents of those variables. So x squared and negative 6x squared, those are a pair of like terms in this 4-term polynomial. Negative 7x and x is also a pair of like terms in this 4-term polynomial. When I've identified like terms, I can then add and subtract those terms. So just like I did up here, I can add or subtract the x coefficients of these two terms, 1 minus 6, negative 5, x squared, and for these two terms, negative 7 plus 1, negative 6x. What I've done now is I've simplified this polynomial by adding and subtracting like terms. Now sometimes, as you saw in the long polynomial earlier, there are terms in a polynomial that have two variables. Okay, this polynomial has 6 terms, and there are some like terms here. I see this term and this term, they both have AB, so they are like. These two terms are identical, so they're definitely alike. This has an A and a B, however, it's A squared B. The exponents are not exactly the same as the exponents in these two terms, so this one is not like those two. There's only one of this type. And then, of course, the 7 is a constant, so it's not like any of these others. So all I can do is add these two, then add these two. This one will stay the way it is, and so will this. 9AB plus 2AB, 11AB. BC plus BC, 2bc plus a squared b plus 7. So we started with 6-term polynomial, we end up with a 4-term polynomial. And then sometimes you'll be confronted with a polynomial plus or minus an entire second polynomial. And it'll be presented like this. Okay, so I have a trinomial, 3 terms, trinomial, and another trinomial. And this trinomial is being subtracted from this trinomial. And that's why I have these parentheses here. It's trying to tell me I'm subtracting this entire polynomial from this polynomial. Now, I've said many times, when you see parentheses, you want to get rid of the parentheses. So that's what we're going to do. Since this polynomial is in the lead, it begins this expression, I can get rid of this pair of parentheses. But in order to get rid of this pair of parentheses, I have to do something with the minus because this minus precedes the parentheses. So I have to use my distributive property and distribute that negative sign while getting rid of the parentheses. So it goes to each term. Okay, now I can identify like terms. I have 2 of these, I have 2 of these, and I have 2 of these. I have 2 constants this time. Okay, 2 minus 3 is negative 1, so negative x squared. Negative 5 minus 1, negative 6x. And negative 4 minus 1, negative 5, so minus 5. So I end up with a trinomial when I subtracted this trinomial from this trinomial. Now, another way that people like to add and subtract polynomials is vertically. So I could have rewritten this like this. And some people like this because this kind of looks like regular subtraction or addition when you're adding and subtracting long regular numbers like 4-digit, 5-digit, 6-digit numbers. You would stack them vertically like this. You would subtract the ones place, then the tens place, then the hundreds place. That's what we're going to do here. We're going to subtract the constants, then the degree 1 terms, then the degree 2 terms. But remember, there's a minus here, so you've got to be careful. Negative 4 minus 1, negative 5. Negative 5x minus x, negative 6x. 2x squared minus 3x squared. Okay, we get the same thing. So it's up to you if you're okay with visualizing the like terms horizontally like this, then that's fine. You don't have to recopy this, stacking it vertically like this. But if this troubles you, if it's a barrier, then rewrite it like this. Maybe this is better for you. Okay, that's it for your first video on polynomials. Vocab, definitions, and adding and subtracting. The next video will have multiplying monomials with polynomials and polynomials with other polynomials.